Hey guys, homework tonight, density calculations. We're going to hop right into it. I'm going to walk you through the first couple problems and then I'll take the training wheels off and let you guys finish it on your own. Let's start with question number one. It asks us, what is the equation for density? Well, you may recall from today's classroom discussion that we define density as an object's relationship between its mass and its volume. Essentially, it's an object's, how compact an object really is. It's how much mass, how much material can fit into a given space or volume. Right? And that determines, of course, whether or not an object will sink or whether it'll float. But even more importantly, perhaps, when we talk about atmospheric phenomena, we're going to talk about how energy is transferred, how weather systems move, and it's all a function of air masses and their associated densities. Likewise, plate tectonics. We're going to talk about how the Earth's crust actually moves, and the driving force has to do with energy being transferred based on differences in density of Earth's materials. So this is going to be a universal theme that we'll see throughout the year. But in order to really understand it, we have to be able to calculate for it and manipulate the equation. So what is the equation for density? Maybe you haven't memorized, maybe not. And if you don't, that's okay, because remember, we have our reference tables. How awesome are these? And the first page of our reference tables, we're going to see that there is an equation box. Check it out. You don't have to memorize any of these. They're all at your fingertips. There's 4 of them that we need to know this year, but for the purpose of today's lesson, we're focused on the last one. There's our equation. Density equals mass over volume. Let's get that right in there. Density equals mass over volume. That's our equation. Now it's helpful to think about, alright, well, what units are going where, because that helps us determine what variables should be inserted when we do the substitution for this. Well, with mass, which is the amount of material in a given object, it's typically defined as grams, right? We use a balance to determine the mass of an object. For volume, that's the amount of space something occupies. Well, depending if it's a liquid, we're going to be using milliliters. Or if it's a regular shaped solid, well, then we can actually solve for volume by doing length times width times height, and that gives us centimeters cubed. Now remember, the answer for density then, it's a derived unit, it's a comparison of mass to volume, should have 2 equations to it. So we should have grams per milliliter, or if it's a solid, centimeter cubed. So you should always have 2 units attached to your density answers. Alright, well that's helpful. Now that's helpful for solving for density. Problem is sometimes we're asked to solve for mass. Sometimes we're asked to solve for volume. Well, how do we do that? Well, it's a bit more complicated, but there's of course a very easy way to do it. If you guys remember the diagram we looked at in today's class, this beautiful picture of mountains, deserts, and valleys, we can remember where these things are, right? Mountains go way up here, deserts and valleys go way down here, and we can make what we call a magical density triangle based on this picture, where we have to cut that triangle in half. So why don't you go ahead and do that for question 2. Make a nice big triangle, and then cut it right in half. And then we're going to subdivide that bottom half again, drawing a line perpendicular to the line you just drew. Now we're left with 3 compartments in the density triangle. We need to label those. Alright, well, since we know we have mountains up here, let's put an M there. Now, of course, that M stands for mountains. That helps you remember where it is, but really, the M stands for mass. Where are the deserts? Where are the valleys? They're down here. D, of course, stands for density. V stands for volume. So there is our triangle. How do we use it? It's actually quite simple. Whichever variable you're trying to solve for, you just use your thumb, cover it right up. For example, if you're trying to solve for mass, cover up the mass, you'll see that you have density next to volume. So mass equals density times volume. Alright, what if you're trying to solve for volume? cover up the V. What are you left with? Mass over density. If you have one on top of the other, that's division. Therefore, volume equals mass divided by density. And of course, we know the equation for density, but if you cover up the D, you're left with mass over volume, and therefore we have mass divided by volume. So just remember, mountains over deserts and valleys. Check your math, check it twice. Alright, let's try one out. We'll do the first one together. Alright, question 3. If a substance has a mass of 32 grams, alright, 32 grams is the mass, and the density of that substance is 0.8 grams per cubic centimeter. What volume does the substance have? So we're trying to solve for volume. That's where we're going with this. Well, then that begs the question, what was the equation for volume? Using your density pyramid, you should arrive at the fact that volume equals, one second guys, volume equals mass over density. Alright, there's the equation. Let's substitute. Volume equals mass over density. Well, we have 32 grams is the mass, so we do 32.0 grams. Don't forget your units here, guys. Over 0.8 grams per cubic centimeter. Before moving on, we got to think about, well, what are the units we want to be left in? Alright, well, figure that out. Take a look. Well, we're solving for volume, so we know it should be centimeters cubed. How does that work? Look at what happens to the grams. They cancel each other out. So what we're left with is cubic centimeters. So really, when you plug and chug, we should be left with 40.0, asks us to round to the nearest tenth, don't forget that 0, centimeters cubed. And there you have it, guys. There's your answer to question 3. The rest is up to you. Good luck tonight. We'll see you tomorrow.